Hi, so we're going to talk about how to import a data set and pre-process a data set for um, machine learning. So pre-processing a data set or prepping a data set before building out your machine learning model is like the first step in actually performing machine learning um, in real life applications. So I have right now um, a Unix terminal, and what we're going to do is that we're going to use NumPy, Matplotlib, and Pandas to manipulate the data set to where it could be, in a structure that's applicable towards supervised machine learning. Okay, so here we have our main working directory. It's our data set is basically going to be 4x tick data. So 4x stands for foreign exchange. It's basically you could trade foreign currencies, commodities as well. It's really popular, and I found a data set through Kaggle, which is very popular for finding data sets that were generated through like the real world. So what I mean by that is that you always want to get data that was generated by real life circumstances. So people might get, if they want to classify digits in zip codes, then people will normally get the zip codes from the Postal Service, because those numbers that were inputted into the data set were actually put into genuine mailing transactions. And so this data set is derived from real life applications. It's based off of the euro and USD, or US dollar, I should say, pairing, major minor pairing. And so what we can do is that we could go into our Python interpreter, Python 3. And so basically with these three libraries, the NumPy library, the Matplotlib library, and the Pandas library, you need to actually download those before you actually run this program, for example, on your own, right? So you could use pip, which is a really awesome package installer for Python. And so I already downloaded my packages, so we could just get going. So we can type import numpy as np, and numpy is basically a math library to perform operations, which is really useful because machine learning, the roots of machine learning is math, so having numpy, a mathematical library, is key. We can import matplotlib, matplotlib.pyplot, and matplotlib is a Python library that allows you to graph data, and then we could use a shortcut as PLT. And we can import pandas as PD. Pandas is really important because with pandas, that's the main way for you to import your dataset into the program. Okay, great. So after we did that, we can actually import the dataset through pandas. So we could dataset, declare a variable, and use the pandas toolkit. And then we could use hashtag import read underscore CSV. And this is basically like a, in Java they call it a method, in C they call it a function. I believe in JavaScript they call it a module. But this is read underscore CSV is basically a tool that you can use that's provided through the pandas library. And this allows you to read in a CSV file, or in other words, a data set. So you can specify the name here. And our data set is called EURUSD, stands for Euro USD dollar. 15 minutes, so that 15M is the time window that you are tracking the candlesticks in the chart in the Forex market. So this is the 15-minute time window, and bid sample.csv. Okay. And so we can enter. And then after importing the data set, we actually have to distinguish between the independent variables, also known as the features, and the dependent variable, which is basically the thing that you want to predict. And so to illustrate what I'm talking about here, could look at this, and you'll see here time, open, high, low, and close. These represent, the time window. This is like the opening price of the Euro USD pairing. The high for the given day, the low for the given day, and the close for the given day. And this is the volume, or the amount of currency that was available for that day to be sold or bought. And so traditionally, the dependent variable, or the thing that you want to predict, or the final output, is the last column. And all columns before the last column are known as the independent variables, or the features. And our goal right now, after importing the dataset, is to separate the independent variable features from the dependent variable vector. And when you're separating the independent variables from the dependent variables, it's always important to keep in mind that we could always have just one dependent variable, meaning that it's always going to be a vector. In comparison with the independent variables, since they're grouped together, it's traditional that you're going to have more than one feature. So the independent variables, rather than being a standalone vector by default, are most likely going to be grouped as a matrix. So we want to separate the dependent variable vector from the independent variable. So basically what we're going to do right now is we're going to create a matrix of features that contains the independent variables. And the independent variables right now are time, open, high, low, and close, and the dependent variable is volume. Okay, so we can just define a variable, an arbitrary variable x, and we could use the data set, which represents our data set, dot iloc. Iloc, you could think of it as ilocate, to make it intuitive. And what we're going to do right now is we're going to separate. Here, I'll show you. So here, right here, dataset.iloc brackets colon, comma, colon, -1 values. So what iloc does, it sort of parses out or separates the matrix or the dataset. And what we're specifying here is take all of the rows or all of the sample instances from the dataset and get all columns except the last column. So you can see here, colon alone stands for everything, and colon -1 stands for everything except the last column. And with iloc, the position of the colon and the colon -1 are very deliberate. The colon on the left side here stands for the rows that you want to grab, and the colon -1, the placement here, stands for the columns you want to grab. And dot values, this means you want to get the values of those positions. And so together, and then we want to get the dependent variable vector that we're going to define as y. We're going to do the same thing as we did with x, which represents the matrix of independent variables over a dataset. So dataset.iloc, and we want to grab all the rows or all the instances of the dataset, and we're gonna, you see here, it's pretty cool because with the Unix compiler, or Unix operating system I should say, actually gives out the number of columns, which is pretty cool because you don't need to count the number of columns. And because with arrays always start at index 0, then we want, rather than specifying 6 right here, since it starts at 0, we just subtract 1. So rather than, this right here is the 6th column, but since the arrays start at index 0, we need to subtract 1 from the total number of element columns. So we say 5. Just do the same thing with the dot values, grab the values. So what this says right here is grab all instances of the sample data of the rows, so all of them. And we want to grab only the last column, which represents the dependent variable vector. That is the output that we want to actually predict down the line. So you press enter. And if you want to see X, just see what it displays. This X represents the matrix object over independent variables. Then you see here, so it has, the date, which is the first here, the time, the open, the high, low, and the close. So the date, the time, the high, the open, and the close. And then if you want to see Y, you'll see here that it's only one array. And so like what we've done now is that we've successfully separated the data, pre-processed the data for our machine learning model by separating the matrix of features and the dependent variable vector. All right, thank you. Please like and subscribe. I'll make more videos to really illustrate these concepts, and thank you so much for watching.